a day of many discussions, and this is just one more thing that we're going to talk about today. Yeah, short introduction. My name is Jervis. I work at Block on the Liquidity wallet, and today I'm really excited to kind of try to put together a playbook for building a self-custodial Lightning wallet. So full disclaimer, the model we're really interested in is a model where you have a full Lightning node running on the mobile phone. So there's supposed to be a sound that plays here. I don't know if people can hear it. Right? So you're sort of familiar. Who doesn't know what that sound is? Raise your hand. Exactly. So if you're gone at some point to pay that will pay, you can relate to it. It's a very recognizable sound, right? And this is typically what our daily spending looks like. And I intentionally selected pictures of fiat credit cards for that reason. You would either purchase some coffee from the local coffee shop or pay our customers for their services. We're usually out and about, and they're very undramatic experiences. We don't really think about it all that much, right? Well, let's just take a second, take a step back, and figure out why so many people like it. First of all, it's instantaneous, right? The gratification gives people that high, the sound too. It's relatively easy. It doesn't have significant mental overhead. In fact, my grandmother didn't start using a credit card until contactless payments became a thing. And then last but not least, from a user's perspective, it is reasonably secure. Visa and MasterCard have done a great job marketing bad impressions of many folks. But hey, we're not here to talk about Visa and MasterCard, right? We're here to talk about Bitcoin. The prevailing experience with Bitcoin, unfortunately, doesn't necessarily always feel that way. I'm sure everyone sort of deep down, as much as we like to get excited about buying hero sats, knows that. Especially if you're using a self-custodial wallet, right? And if you think about what a customer's experience using Lightning should feel like, it wouldn't be enough to just match it. Because users are going to be like, why am I going to use this other thing? It should strive to be better wherever it can. And if Bitcoin were to become like digital cash, if we want to spend and use it, it does help to sort of start by asking ourselves some questions. The first one being like, what are some desirable properties of cash? And how can we likewise bring that for digital payments? Maybe that's how we make Bitcoin a little bit more interesting, right? So the first thing is, well, we want it to be private. No one except the parties involved should necessarily be aware that the transaction happened. Second, it needs to be portable. Whenever you want to make a transaction, you shouldn't need to pull up your desktop, fire up Sparrow wallet, and sign stuff. You should just not do that. That just looks funny. And secondly, and more importantly, in fact, it needs to be friendly. The mental overhead shouldn't be overwhelming. When you onboard people, they shouldn't need to purchase a Raspberry Pi. They shouldn't need to provision file instances, as much as I like to do it myself, or know what LSP stands for. I presume most people know what that stands for, but most folks out there, quote unquote, normal people, don't know what that is and shouldn't. Custodial wallets today replicate an experience that's very close. We love using things like Cash App. We love using things like Wallet of Satoshi. But that stops short of our digital cash aspiration. And these portable and friendly aspects remain a point of friction for average consumers. And the truth is, when we have conversations about Lightning today, we make certain Lightning assumptions about nodes and signers. And it feels like it's designed for servers. Right, no one really talks about how it's going to work for someone with a mobile phone. Yet people spend mostly when they're out and about. In other words, the way of framing this is mobile really needs more innovation or ideas or experimentation within the space if we have any desire to help more people within the globe use it. And we have a lot of Bitcoin engineers making great apps, but very little mobile expert and practitioners going in the other direction. And this is understated because I personally come from a mobile background, and mobile engineers have had to learn in a very hard way how people use applications and things when you're out and about. And that's a very different user experience to consider versus like a web page, for example. However, today, if you were to be a mobile developer with many years of experience working on mobile apps, you would come to Lightning and be extremely intimidated by all the stuff you need to kind of hold in your head. So what's this talk about? Well, this talk aims to be an almanac for these mobile engineers. At least we try to be current for the next 1 year, because I'm sure a year from now, this will change a lot. And we will present typical challenges confronted by mobile self-custodial wallets. And we'll also enumerate through a list of tools that emerge to kind of help out with them. So I think, given that this is sort of talk kind of like for folks who might not necessarily know a lot about Lightning, let's talk very briefly about Lightning. We're just going to speed through it. So let's introduce our usual cast, Alice and Bob. And let's say Alice wants to go to Bob to buy some coffee. To be able to send payments to Bob, she asks Bob, hey, can I open a channel? And Bob gives her a list of conditions, and Alice then agrees and funds the channel with 1,000 sats. She signs a funding transaction, sends it to Bob. Bob signs it, looks like cool, sends it back to Alice. Alice then broadcasts it in the Bitcoin blockchain. And for the sake of simplicity, let's just say that Alice and Bob are looking out for 6 confirmations. So an hour passes. Obviously, hopefully, she's not waiting an hour for a coffee. They both say that they're ready and the channel is officially established. And for the sake of being able to talk about liquidity, we will introduce everyone's familiar object feeds. And so now, say Alice wants to send 400 sats, she can do it. She wants to send 200 more. And say for some reason Bob wants to send her a refund because she's really nice or whatever, and Bob can send back conversely. And this is happening instantaneously because Alice and Bob essentially use the Lightning protocol to keep track of IOUs on their own. I know folks might know the more technical, precise term for this, but just bear with me here, we're just going to call it IOUs. So let's make this example a little bit more interesting, shall we? Say Alice wants to pay a contractor or a ski instructor, but unfortunately she doesn't go to do business with a contractor or go to the ski resort all that much, so she doesn't have a channel with that. But thankfully, they both drink coffee, so Bob has channels with them. And now, for the sake of being able to talk through some of these liquidity scenarios, let's give them some beats. And Alice can now send 200 sats that goes through Bob. And likewise, she can send 200 sats that goes through Bob to the ski instructor. And as it turns out, Bob is extremely well connected. In fact, he's so well connected, he's connected to museums, theaters, schools. And so Alice is able to pay for goods and services through Bob. And yeah, so let's just stop here. That's enough of a Lightning example. But a few immediate questions that kind of jump out in your head, or at least in the back of your head. And the first is, how does Alice and Bob keep track of the IOUs? The second is, if everyone is Alice, how do we make sure, by everyone, I mean everyone on board is Alice, how do we make sure that every Alice has a Bob? If Alice is expecting to receive instead of send, I mean, in that example, Alice is sending, but if she's trying to receive some sets, how would that work? And last but not least, like, how can Alice be aware that she has a connection to whomever she wants to pay? In other words, how does she make sure that she has the latest current, Lightning network graph? And as if these questions aren't hard enough, here's another thing to just kind of make everything a bit more dramatic. A phone has limitations that make these questions a little harder to solve. The first thing is mobile devices are not always online, so you cannot expect it to always be there when you need to send a payment or receive a payment. The second thing is they have limited resources, specifically the battery. For example, operating systems typically do not allow developers to have reliable access to the background CPU for that reason. If you flip your phone to low power mode, for example, you definitely are not going to get CPU cycles. So just something to kind of put in your head. But we want to talk about some technical solutions. So some of the helpful ways, a helpful way I have come up with to think about them are these 4 domains. And let's introduce them very shortly. The first one is liquidity. The second one is pathfinding. The third one is backups. And the last one is multi-sig. So typically when I talk about self-preserved lightning model, I like to put stuff in these 4 buckets. And to be completely honest, they do cross sometimes. They're not perfect buckets, but I use it as an internal framework when I think about things that I could potentially improve within a self-preserved or lightning wallet setting. So let's first start talking about liquidity, which is what a lot of people love talking about, right? And when you think about liquidity, it basically is what channels are available for a customer to use. And in other words, it's like how much money can a customer send on Lightning. This subject becomes very important because it determines how users access the Lightning Network. And so let's just go through some of the challenges that you typically confront with liquidity. The first one's connectivity. So again, it's like how do we make sure that every LS has a fob? Sometimes it's hard to find a path to an intended payee. The second problem is what I call like a cold start problem. If you were downloading an app for the first time, you have no channels. It's kind of painful because it kind of prescribes you to have to wait for some kind of on-chain confirmation. And if you don't have any inbound liquidity, when say if Alice starts off in that example with most of the fees on her side of the channel, she's not going to be able to receive money, for example, and that's pretty not great. And the last one is what I call channel decay. Another way of restating this is an unbalanced channel. So the channel over time becomes less useful if it's not balanced, essentially. So to get started, let's talk about connectivity. I think, and this is also a topic that's well emblematic because most people have kind of accepted that we need Lightning service providers, given that mobile devices are not always online. So you delegate the responsibility to something that's always online, a Lightning service provider. So this idea is pioneered by Greece, I believe, and like an internet service provider, it provides connectivity for users on the mobile network. Sorry, on the Lightning network. So you might remember this slide, and a lot of you in the audience probably in the back of your head go like, it's an LSP, and yeah, that's kind of the motivation for me creating this example. You have LSPs that kind of help users connect and have reliable payments just by extension of being very well connected. And we have many popular options for this, right? We have Voltage, we have Sequels, they have groups outside, you can talk to them about it. LSPs also do come with additional features that do help with managing liquidity easy. And this actually serves as a good segue to our next problem, which is the cold start problem. For example, like you're Alice, and say you want to receive some money from home, and you have no inbound liquidity. None at all, right? Like, you could stand there with Bob for an hour and wait for a channel to open. But thankfully, we have somewhat of a solution. I think the name of this is just-in-time channels. And it's part of a LSP spec. Specifically, it's called LSPS2. It aims to kind of address the inbound liquidity problem. And this next slide, I do ask for you to bear with me a little bit as we kind of stare at this diagram. Say Alice wants to receive some money and doesn't have a channel yet. She needs to first have LSPS appear. And to purchase this inbound liquidity, basically she gets some opening parameters from the LSP, officially says like, oh, I want to buy this channel. The LSP returns some of the channel ephemeral channel information. And then Alice generates an invoice. Alice generates an invoice and adds a route hint. That is the LSP, essentially saying that the last hop to Alice is the LSP. And she constructs this invoice and sends it over to Bob, which Bob then fulfills the invoice. And when the LSP receives the HTLC, they hold it there, open a zero confirmation channel to Alice, right? And the moment the channel becomes ready, it makes that final hop from the LSP to Alice. And the great thing about this is it is instantaneous. No one really needs to sit there and wait for 10 minutes. So to learn more about this, I wish I could dive into more details. To learn more about this, do come to John's talk tomorrow at this stage at 3:30, Unleashing the Quant's Potential, and he will dive into more interesting LSP specs, which many people might find interesting. The next one is channel decay. So, as I said before, channels do become imbalanced over time, and you can run into insufficient inbound, outbound liquidity issues. Everything I mentioned past this point are works in progress, but they're coming, and I can feel it in my bones. Next year, this time, hopefully, is a thing. So the first thing is splicing. So splicing can be really thought of as resizing the channel. And to give us a more concrete example to work with, just imagine if this is our channel state right now. Alice wants to send 400 sats to Bob, but she obviously only has 200 sats on her side of the channel. She doesn't have enough beats. She could open a new channel, which is kind of wasteful because then she'll have 200 sats just sitting there, or close and open a new one, which is not ideal because you have to put up 2 on-chain transactions and pay for a fee twice. That's what splicing aims to help with. Using just one transaction, she can splice in some additional liquidity, and all of a sudden she can now make the 400 sat payment. And another solution to this is swap and potentium. It is actually a very elaborate protocol. Like 20 minutes, 2 hours before this presentation, I was frantically thinking I need to put some diagrams up for it. And I realized if I did it probably would overrun, this presentation will overrun. So I'm just gonna hand wave my way through this and kind of describe how it works. So the way swap and potentium works is you have an on-chain wallet, and every time you generate an address, it generates an address with outputs have spend conditions, again, hand wave, that ensure that the user does not double spend LSP, hand wave. When Alice shows up at a coffee shop, right, and says that Alice does not have enough liquidity in the channel for coffee, Alice can offer the LSP or UTXO as backing, hand wave, and get into a pure swap-ish protocol. Then Bob pushes the HTLC for Alice, so she now has a little bit more liquidity, and Bob doesn't have to be, LSP doesn't have to be worried about double spends because of that special UTXO, and now Alice has the liquidity to make the payment. And that was my last hand wave. So that's liquidity. Now let's talk a little bit more about pathfinding. So on mobile, again, we're talking about self-custodial like mobile wallets here. Some pathfinding challenges include the devices are always offline. Well, I didn't mean to say are always offline, I meant to say are not always online. And so they don't really listen to gossip, right? And if you're trying to construct a network graph, like, it's going to be stale. And worse network graphs also tend to be large. In fact, if you were at the RX talk earlier today, you will know that there are 16,500 nodes and 73,000 channels. And hopefully, if we're all lucky enough, that number will continue to grow. Thankfully for this, specifically designed for mobile use cases, we have rapid gossip sync. And it's perhaps worth noting at this point that this is a semi-trusted model, so it's not entirely trustless. It does require you to run a server. And essentially, the way it works is you have a server on the left-hand side. It's a semi-trusted model. You can run your own RGS server. And there are 2 ways a wallet can fetch data. The first one is it can pull the full network graph and load it. The second one is it could say, oh, like I last talked to the RGS server at this point in time. Get me all the deltas starting from this point. And the RGS server will send it to the wallet. And these payloads tend to be really small. Payloads, they don't take like minutes or seconds to even sync, as Art will tell you. So it's really ideal for most mobile wallets. The next one, and this is my next hand wave is flight pass and trampoline. At some point, maybe we don't need RGS, right? Maybe like our LSP can be the one who does the pathfinding for us. But how do we do it without the LSP knowing where you're sending your payments to? Because you don't want LSP to learn your entire transaction history just by extension of you using LSP. So this specific technology, blind pass and trampoline, it's basically a combination of being able to assign specific nodes within your route to be trampoline nodes that end up being delegated to construct the full path. So trampoline nodes and chunks of paths to construct the full thing. The chunks are blended paths, and the trampoline are the trampoline nodes. And wave. But that's basically pathfinding. That isn't something that we can do yet, at least the last one. Now let's talk about backups really quickly. Funny enough, this is perhaps the thing that people overlook the most, maintaining liveness in their channel state persistence. You want to maintain a list of channels of other nodes, and you also want to maintain the channel state for every payment you make or receive. It's basically like making sure you have a good accounting department. Else you got to lose track of your accounts and you will get paid claims, and you just have to take things that paid pays, which is not great. Unfortunately, relying on users' mobile devices are not good enough because users do lose their phone, and losing this data could lead to loss of funds or potentially like an entire wallet. So what are some backup challenges for mobile wallets? The first one is platform-specific details are hard to get right or wrap your head completely around, because iOS and Android like to do things differently, and if you want to use a cloud service provider to upload stuff to the cloud, then you're dealing with different cloud providers too. The second thing is like encryption. You want to encrypt your data because the truth is, if someone can exfiltrate your channel state from your mobile device, they can theoretically piece together your transaction history. Not ideal. So what can we do about this? Sort of unsurprisingly, it's another LDK project. It's called Version Storage Service. It's a readily available service in like RGS. You can run your own version storage service server. And it's designed such that it allows for restoration of channel state. It also ensures that users can regain access to their funds in cases of like a device or data loss. And the way it works is like this, and you don't really have to squint, I'm just going to describe it. The mobile app authenticates with the VSS server. On each payment, like the user sends and receives, it records the state into storage. The project is great because it looks elegant and simple, but it does help you handle client-side encryption, version verifiability, and also allows you to customize kind of the storage layer over there for different cloud providers. It's really flexible. It's going to expand to Wave 1 and Justice that we'll mention later in a second. But that pretty much wraps up what I wanted to talk about backups. And now for everyone's favorite, multi-sig. Unfortunately, Lightning multi-sig is not really a thing yet. My colleague Jesse will tell me there's a cat version of it, where you sign into a Lightning Taproot output. But the version where you produce a threshold signature to advance the channel state is not really a thing yet. And then you ask, okay, so what are the challenges? Well, the first one is we need Taproot channels. That is being worked on right now as I speak. And basically, the other thing is we lack a security proof. I'm sure everyone has heard this like 20 times by now, which is basically the idea that if like two peers get into a channel, it's abusive, and the user key could be Frost. We don't have security proof that that model of using multi-sig and Lightning works. And even with those things in mind, assuming we have Taproot channels, assuming we have security proof, we still need to handle sort of some of the interactivity aspects of the signing protocol. Specifically with Frost, you have two rounds. First round where you have to exchange nonces, and the second round you exchange the voucher signature to sample the signature. And we have some ideas on how to like optimize that, get to a point where we have a reasonable user experience for customers. But I don't think, at least to my knowledge, that there has necessarily been a formalization of what it would look like. Which means that I kind of leave you with a question mark. It's obviously everything is a work in progress. There's a theoretical component to it, which is still it's fairly important to work out. But hopefully, this time next year, or this time 2 years from now, I have some stuff to put in this slide here. So yeah, when we talk about the future, let's talk about the future, right? the first one, I think, for me personally, is sort of important. It's important for multiple devices. Because right now, you can have your Lightning wallet, self-custodial Lightning wallet on your phone. You probably don't want to run it at the same time in your iPad, because if they both have different channel states, you might end up gutting yourself because you're going to publish an old state, and someone's going to publish a punishment transaction. Don't want that. So yeah, not ideal. It would be really nice if I could have my Lightning wallet running my phone, have the same one running on my computer, so I can buy stuff. But today you cannot really do that. But it's actually going to change because remember I said from before that version storage service is going to do more than just helping back up stuff. Version storage service is essentially going to be the layer that synchronizes the channel state throughout all your devices. So that is the end goal here. And the last three things, async payments, tracking routing, blinded paths, and both well, they all kind of feed into the enhancement of using Lightning on mobile. Async payments is the big one, because right now, if your phone is locked, and say I want to send some stats card right now, and this phone's locked, and I fire up my computer and do with everything, it will never get to him because it's not online. Not ideal, but we have a path to fixing it. In fact, the path looks something like this. And you'll see that asynchronous payments requires both well trampoline routing, both route requires blinded paths. Private server-side pathfinding requires blinded paths and trampoline routing. So this is sort of like what the dependency graph looks like, if you will. All right, so we got past the flash. Now let's talk about Playbook, which is what everyone is here for. It is the quadratic formula of whatever I'm promising here. That's exciting. Unfortunately, as I mentioned earlier, the first step is actually use LDK, because a lot of the stuff that I've mentioned, I've only really found solutions for through the LDK project. And with LDK node now, which is recently released, you can actually get a Lightning node up and running fairly quickly, 15 minutes, guaranteed. And for some of these domains, let's talk about like the steps. What can you do? Liquidity, connect to an LSP, plenty of options. Go talk to C equals, go talk to voltage. They have a few things to say. Keep the liquidity requirements you have in mind, because you might want to use some of the automated liquidity management strategies, and it's also dependent on whether or not these LSPs will support it. For pathfinding, wire up the rapid gossip saying it's your best bet today. Hopefully that changes. For backups, use something like version store service. Or if you have intimate mobile knowledge, you're probably fine writing some of this stuff on your own too. Just be very careful. And for multi-sig patients, it's coming in 2 weeks. So to wrap up, right? Running a Lightning node on mobile has really come a long way. Going into 2024, we do actually have a few tools at our disposal to craft an experience that's reasonably good. Where I'm really interested to take this conversation, that's for folks to maybe if you want to talk a little bit more about this. The first thing is, can a competent mobile engineer today easily start building a self-custody Lightning wallet without needing to know everything about Lightning? In other words, can we create a suite of tools that expose just the right amount of abstraction, such that a mobile engineer can feel at least somewhat empowered or confident in building something without losing user response? And how do we support more Bitcoin-curious developers, right? Start building on Lightning without needing to read the full literature on how someone could cause you to lose funds. That's very scary. And that's it. Obviously, I'm on the interwebs. I'm not sure how NPubs are typically distributed, so you have my X and GitHub information. We'll also love to chat outside of this talk. So yeah, thank you all for coming, and I hope this was at least somewhat useful.